Welcome back to another explainer. I am so pumped for this one because today we are unlocking an absolute superpower in the tech world. We're talking about mastering the foundations of secure web databases and defensive SQL programming. Honestly, it's wild, but SQL injection is still one of the most common web vulnerabilities out there, despite being literally decades old. So if you're a beginner, a student, or maybe an aspiring freelancer looking to really accelerate your technical career and become an absolutely indispensable asset, well, you're in exactly the right place. Grab your notebook, get focused, and let's get right into it. Okay, let's dive into this. Here is our structured roadmap for building impenetrable backend architectures today. We'll start with the data treasure, move on to SQL, the drawbridge, look at deadly traps to avoid, cover building your database fortress, and finish up with your 4-week action plan. Section 1, the data treasure. So, in our hyper-connected digital economy, a client's data is arguably the single most valuable corporate asset they possess. Just think about the critical information modern web applications are holding. We're talking user profiles, financial transactions, access controls, highly proprietary company data, the whole shebang. And whether it's a multi-billion-dollar e-commerce platform or just a simple corporate blog, businesses are absolutely desperate for developers who can protect these vital assets. They don't just need people who can build flashy visual interfaces, they need engineers who can construct secure backend pathways to safeguard this information from devastating security breaches. Section 2, SQL, the drawbridge. So you might be wondering, how exactly do our applications reach that data treasure in the first place? Well, we use SQL, or Structured Query Language. You can kind of think of SQL as this universal drawbridge for relational database management systems like MySQL or Postgre. It's the highly structured bridge that safely passes instructions from the front-end web application server all the way down to the raw server hard drives. So every time a user interacts with a website, like, say, inputting credentials into a login portal or running a catalog search, the backend server takes that dynamic input and generates a query that literally has to cross this drawbridge. Let's move to ANSI and see how this builds a truly secure ecosystem. Any dynamic user input crossing that drawbridge must survive a really rigorous 3-step execution sequence. Step 1 is input sanitization and typing. This is where the backend screens strings and actively forces data types, like making absolutely sure a user ID is strictly parsed as an integer. Step 2 is structural separation. Here, the database parser splits compilation logic completely apart from the literal variable text, preventing those user inputs from rewriting execution structures. And step 3 is isolated fetching, meaning the database engine only ever outputs the precise fields allowed by the application's predefined permission schema. Section 3, deadly traps to avoid. Okay, now that we understand how the drawbridge operates, we really need to talk about the structural software flaws that can leave it wide open to attackers. And everything we discussed today is anchored on this absolute golden rule of secure software engineering: never trust user inputs. Honestly, I want you to burn this into your memory. Security cannot be treated as some decorative feature that you just tack on to a project right before launch. No way. It absolutely must be woven inherently into the architecture of your application from day one. And this brilliantly illustrates what happens when you ignore that rule. Things get messy fast. On the insecure side of your screen, we have string concatenation. This is the super dangerous habit of dropping unvetted text right into a query string. When you do this, an application can accidentally parse data inputs as executable logical statements, which completely breaks intended access barriers. But right next to it on the secure side, we have prepared statements, also known as query outlines. Here, you compile the query outline first. Because the outline is already set, any incoming data is strictly treated as a literal text parameter. This completely neutralizes any potential modifications to your query logic. It's a total game changer. Now, before we move on to building our defenses, I want to step in for a second as your technical coach and warn you of 2 other massive security pitfalls that globally cause systemic vulnerabilities. First up, literally never hardcode database credentials or root passwords in plain text inside your code repositories. Always use .env environment files instead. Second, do not neglect software patches. Running out-of-date database engines or system dependencies just leaves known technical vulnerabilities active. Keep those server platforms updated for sure. Section 4, building your database fortress. All right, now it's time to construct impenetrable walls around our treasure, starting with 5 code-level defenses that neutralize malicious input before it ever becomes a problem. We've already covered parameterized queries, right? Those are your baseline. Next is strict input whitelisting. So don't just block the bad, explicitly only allow the known good. Then we have ORMs, or Object Relational Mapping, to abstract away raw text interactions. For legacy systems, character escaping adaptations are an absolute lifesaver, so literal data characters aren't accidentally interpreted as query boundaries. And finally, automated SaaS tools ensure you're constantly auditing source code before it ever even reaches production. But what happens if the code fails? Well, that's where our second bucket comes in, architecture-level defenses, to add massive structural security. We start with the principle of least privilege. Basically, give a service only the exact permissions it needs and nothing more. We can also lock operations safely inside the database using compiled stored procedures. Next is the suppression of public error diagnostics. Never, ever show verbose database errors to external users because those stack traces reveal your internal structures right to attackers. Finally, we screen incoming networks by deploying web application firewalls, and we isolate endpoints into completely closed internal VPNs using database microsegmentation. Now, what's really interesting about this slide is that arming the guards of your fortress doesn't have to cost a dime. Look at these 4 essential free tools. Visual Studio Code lets you equip security plugins to spot dangerous query formats right as you write. Docker Desktop allows you to build safe, isolated sandbox containers for testing without risking your main system. dbeaver Community Edition gives you a super clean visual interface to manage multiple database types universally. And SonarQube Community Edition provides static code analysis to check your codebase for potential security bugs and structural oversights. Section 5. Your 4-week action plan. You know, understanding the theory is excellent, but becoming a trusted consultant requires real action. Building professional expertise takes consistency, time, and hands-on practice. Here's your step-by-step path. Kick things off in week 1 by mastering foundational relational database structures and basic SQL mechanics. By week 2, you'll be writing scripts with back-end driver integrations with parameterized queries. Then step up your game in week 3 by manually tracing and patching insecure legacy files in a safe local test environment. Finally, wrap it all up in week 4 by assembling a public GitHub portfolio of your secure boilerplate templates to market your freelance services. So the crucial point is that the absolute best way to learn is by doing. Do not wait for a perfect moment. Take action today. I highly encourage you to install a local database on your machine immediately, run your first structured queries, and really start translating these defensive fundamentals into real-world code. I want to conclude with this provocative final thought as you step out to apply what you've learned. Will you just build flashy visual interfaces, or will you actually engineer the secure pathways that protect a business's most valuable asset? The demand for developers who prioritize data safety is only going to grow. Thank you so much for diving into this explainer with me, and I absolutely cannot wait to see the impenetrable fortresses you build.